Alright, greetings. This is the Exam 3 practice. Getting ready for Exam 3, the practice test. And I'll do these out on a separate piece of paper here because there's not nearly enough room. Alright, for the pair of functions, find the indicated sum, difference, product, or quotient. Number 1, he's asking me to find f plus g of 2. Alright, so this translates to f of 2 plus g of 2. What's the f function? The f function, f of x is equal to x plus 7. So if I'm going to find f of 2, this is 2 plus 7, which is equal to 9. F of 2 is 9. And what about g of 2? Alright, g of 2. So the g function, g of 2, let's see. Well, let me first just write the g function. G of x equal to, what is the g function? It would be nice if I wrote it down. X plus 3. So g of 2, in place of x, I'm substituting 2, adding 3, so this is 5. So g of 2 is 5. So f of 2 plus g of 2 is 9 plus 5, which is 14. Letter C. Letter C. Number 2. We start out by writing the functions first. Number 2. F of x equal to negative 2x squared plus 5, g of x equal to x plus 4. And what is he asking me to do here? He's asking me to find f minus g of negative 3. So this translates to f of negative 3 minus g of negative 3. So f of negative 3, f of negative 3. So in place of x, I'm going to substitute a negative 3. So this is minus 2 times minus 3 squared plus 5. Minus 2 minus 3 squared is 9 plus 5. This is a negative 18 plus 5, which is a negative 13. What is g of negative 3? Well, there's the g function right there. G of negative 3, in place of x, I'll substitute negative 3, and I'll add 4. So this is a positive 1. So f of negative 3 minus g of negative 3. F of minus 3 was a minus 13 minus whatever g of minus 3, that was 1. So this is a minus 13 minus 1 combined. A minus and a minus is a minus. Minus 14. Letter B. Number 3. Number 3. F of x equal to 5x minus 5. And g of x, see if I get a darker pencil here. G of x, number 3, equal to, well, 2x squared plus 14x plus 4. And he's asking me to find f divided by g of a negative 2. So this translates to an f of negative 2 divided by a g of minus 2. And let's see, f of minus 2. F of minus 2. Here's the f function right here. So in place of x, I'm substituting in minus 2 and I'm subtracting 5. Minus 10 minus 5 is a minus 15. So I got a minus 15 in my numerator. And let's see, g of minus 2. Here's the g function right there. G of minus 2. In place of x, I'm going to substitute negative 2. So this is 2 times negative 2 squared plus 14 times negative 2 plus 4. Negative 2 squared is 4. 2 times 4 is 8. Minus 14 times a minus 2 is a minus 28 plus 4. Or 12 minus 28, which is a negative 16. A negative 16. So what have I got here? A negative, f of minus 2 is minus 15. G of negative 2 is a minus 16. So a negative over a negative becomes a positive 15/16. Positive 15/16. Number 3, letter C. Number 4, h of x, f of x, that's h of x. All right, I can make that into an h. Number 4, h of x, x minus 4. And g of x equal to radical x plus 3. Find, I have trouble writing h's, I guess. Find hg of 0, which translates to h of 0 times g of 0. Notice there's no symbol there. But there's no symbol, it implies multiplication. H of 0, what's the h function, right? H of 0. So in place of x, I'm putting in 0, so it's 0 minus 4, which is minus 4. And then g of 0, so in place of x here, I'm putting in 0, so g of 0 equals the square root of 0 plus 3, which is the square root of 3. Now I need to multiply these two, so a minus 4 times radical 3. Minus 4 times radical 3. H of 0 times g of 0. All right. Number 4, letter C. Negative 4, the square root of 3. This times that. Number 5. Number 5. F of x defined as 6x minus 7. And g of x defined as 3x minus 9. He wants me to find f subtract g of x, which translates to f of x minus g of x. All right. So here's a case where he doesn't give me a value like he did in the previous ones. F of x, well, f of x is right here. 6x minus 7 minus, and in parentheses or brackets, g of x. I got to put this in parentheses or brackets because this minus sign is going to change the signs of the two terms within, in my case, my bracket or parentheses. A minus times a positive is a minus times a minus is a positive. Combining like terms, 6x minus 3x is 3x. A minus 9 combined with a positive, a minus 7, combined with a positive 9 is a positive 2. Positive 2. And number 5, once again, they seem to like letter C here a lot. 3x plus 2. Alright, that's pretty straightforward. Number 6. F of x defined as 3 minus 9x. And g of x defined as negative 6x. Negative 6x plus 9. He wants me to calculate f plus g of x, which translates to f of x add g of x. Well, here's the f of x. 3 minus 9x added to the g function minus 6x plus 9. Alright, so see, a minus and a minus. Minus 9 combined with a minus 6 is going to be a minus 15x. 3 plus 9 more is 12. So we're looking for minus 15x plus 12. Here again, he likes letter C. Minus 15x plus 12. All right. Number 7. F of x defined as 8x plus 7. G of x defined as 6x minus 2. And he wants me to find fg of x, which translates to f of x times g of x, which becomes, let's see, f of x is 8x plus 7 times 6x minus 2. Our old favorite FOIL, 8x times 6x, 48x squared. The outside terms, 8x times a minus 2 is a minus 16x, 7 times 6x is a 42x, and the product of the last terms, a positive 7 times a minus 2 is a minus 14. 48x squared, let's see, a minus 16 and a positive 42. That's going to be a positive, and looks to be 26x minus 14. What do we got here? Number 7, looks like letter C again. Yeah, there it is. There it is, 48x squared minus plus 26x minus 14. Gotta FOIL this out, but you know, how many times have you FOILed Algebra 1, intro algebra? All right, composite function, I'm sorry, difference quotient. Difference quotient. First of all, the difference quotient is defined as f of x plus h minus f of x, and that all divided by h. So, what function are we working with? F of x is equal to 7x minus 5. So I need to find, first of all, f of x plus h. So in place of f of x plus h, so in place of x, I'm substituting in x plus h and subtracting 5. So what is this? 7x plus 7h minus 5. So this right here, I figured out to be a 7x plus 7h minus 5. Subtract f of x. So if I subtract this, f of x, subtract this, what ends up happening is the signs change. The positive becomes a negative, and this negative 5, because I'm subtracting this, becomes a positive. And then this is all over h. And combining some terms here, the x's cancel out. And the minus and the positive 5 cancel out, and you get 7h divided by h. And then finally the h's cancel out. What could be sweeter? What could be sweeter? And once again, our favorite letter is letter C, 7. Alright. These usually, if you're doing it correctly, these signs really simplify down to as many as maybe most 3 terms. You're not going to have something crazy like this, and this looks weird too, so I say weird, but it's not a mathematical concept, is it? Alright, if I can slide this up here a little bit. Very good, Mr. Holmes. So once again, the difference quotient is f of x plus h minus f of x divided by h. And here we got f of x defined as 7x squared plus 9x. So what I need to do first is find this guy right here, f of x plus h. So in the function, wherever I see x, I'm going to substitute x plus h. So this is going to be 7 times x plus h, but I got to square it, plus 9 times x plus h. Now I tell you, have this in your notes, how you FOIL that out. This FOILed x plus h quantity squared is x squared plus 2xh plus h squared. Have this in your notes, you don't have to bother FOILing it. And distributing 9x plus 9h, 9 times x plus 9 times h. This becomes, if I distribute the 7 times the terms in the parentheses here, 7x squared plus 14xh plus 7h squared plus 9x plus 9h. That's a 9. Now, I've got to subtract f of x. I've got to subtract this. I have to subtract now. What's going to happen is simply the terms within, the signs of the terms within this parenthesis are going to change. This is going to become a minus times a positive is a negative. Negative times a positive is a negative, and this is all over h. Now, if I've done this correctly, I should get all kind of nice cancellation. 7x squared cancels with a minus 7x. Minus 9x cancels with a positive. And I think that is that. What's remaining? 14xh plus 7h squared. Got it. Plus 9h. All divided by h. Now, here again, if I've done this properly, every term in the numerator should have an h common factor. 14x plus 7h plus 9, factoring out that h. And then finally, the h's cancel out. So what number is this? This is number 9. 14x plus 7h plus 9. So we've gotten away from letter C. We now are at letter A. 14x plus 7h plus 9. 14x plus 7h plus 9. Yeah, at most, even when you get something that's squared, a function that has a square term, at most you're going to have your answer be 3 terms here, all right? But they all had 3 except for the last one, so yeah, it's kind of a guide, I guess, but best way is just to do the problem out. Just do it out, you got it. All right, find the composition of functions. All right, composition of functions. So, number 10. It defines f of x as the quotient of x minus 1 over 7. And he tells me that g of x is 4x plus 1. G composite f of 29, which translates to g of f of 29. So I want to calculate what f of 29 is. All right, get an answer. Whenever answer this just gives me, I'm going to find g of that number. F of 29. Well, f of 29. Here's the f function right here. Take the x value, which I'm going to replace with 29, subtract 1, and then divide it by 7. And nicely, we get something that's divisible by 7. 28. So this guy is nothing more than 4. All right, I'll find g of 4. All right, there's a g function right there. In place of x, I'm substituting in 4. And adding 1. So this is what, 16 plus 1 more. That looks like 17 to me. And we're back to our favorite number 10. We're back to our favorite letter in the alphabet, letter C, 17. Number 11. F of x equal to 8x plus 8. G of x is this trinomial, negative 3x squared, plus 9x minus 4. Find g composite f of negative 4, which translates to g of f of negative 4. Calculate this and then find g of that number. F of negative 4, here's my f function right here, f of negative 4. So in place of x, I'm substituting in negative 4, multiplying it by 8, and then adding 8. So this is a minus 32 plus 8, which is a negative 24. All right, so this is a negative 24. Find g of that. G of a negative 24 squared. I'm sorry, a little ahead of myself here. G of negative 24. I was just surprised I was going to square this thing. So this is minus 3 times x, but x is negative 24. I'm going to square that, add 9 times 24 minus 4. So here's a case where I'm going to need my, well, I can actually do it pencil and paper. What's 24 squared? This is what, 16, 96, 8, 4, 6, 17, 576. And 9 times 4, 36. This is 216. And subtract 4. And what's 576 times a minus 3? 18, 21, 22. Looks to be a negative 1728 plus 216 minus 4. So I got a negative 1732 and 216, subtracting 5, 1. What happened here, ladies and gentlemen? What happened here? What happened here? I'm coming up with something that's not one of the answers. A negative 732 and a positive 216. Where am I getting here? 6125. I'm getting 1516. That's not one of the answers. So let's see what we kind of go back over this and see where Mr. Gomes made a mistake. First of all, did I copy the problem right? 8x plus 8. All right. Minus 3x squared plus 9x minus 4. That looks good. G composite f of a negative 4. G composite f of a negative 4. Alright, so that's G of f of negative 4. What was f of negative 4? Alright, that was 8 times negative 4 minus 32 plus 8. That's a minus 24. So that looks good. Now what is G of a negative 24? So it's a minus 3 times 24 squared. So that was 96. 576 and a minus 3 times that. That's going to be big. Plus, well, here's my problem right here. Alright, that's why we do things step by step. Finding my x value is negative 24. So what ends up happening, it makes this guy negative, which makes this guy a negative 216. So I've got a negative 1728. A negative and a negative would be a negative 220. 16 and 4 more. This would be 849, negative 1948. Okay, there we go. So, sometimes I do things by mistake on purpose, but that's a perfect example. It wasn't coming out right. By that I mean I wasn't seeing the answers, but I did everything step by step. I didn't do anything in my head, which allowed me to go back and then see here, in place of x, I should have been substituting a negative versus a positive. Made this whole product negative, which threw my whole answer off, but now I got it correct. So I actually wish I did that on purpose. It's good to do things wrong every now and then, just to show you people how you can correct your error. Just don't want to be doing things wrong all day long. It's kind of old. Alright, moving on. F of x. You don't get too rattled when you make a mistake. You just hang in there, and if everything is written properly, you'll find your mistake. Or, if you did it again and you still get the same crazy answer, what I would suggest you do is just cross it all off. Get a fresh piece of paper. It's a good idea to have plenty of scrap paper when you're doing these exams by your side. Number 12, what are we asked to do here? F composite G of x, which is f of x sorry. Which translates to f of g of x. I can say it properly. It'd be nice if I write it properly. All right, so what's g of x here? G of x is 4x minus 1. So wherever I see x in the f function, I'm going to substitute in the g of x function, which is 4x minus 1. So this is going to be, in place of x, I'm going to substitute the g function. So this is going to be 5 times 4x minus 1, add 6. Add 6. Distributing. 5 times 4 is 20, times x is x, 20x. 5 times a minus 1 is a minus 5 plus 6. And minus 5 plus 6 is a positive 1. 20x plus 1, letter D, number 12. All right. 13. What do we got here? F of x equal to 4x squared plus 5x plus 4. G of x equal to 5x minus 8. G composite f of x, which translates to g of f of x. What is the f function? It's right here. 4x squared plus 5x plus 4. Find g of this. So wherever I see x in the g function, I'm substituting in this trinomial. 4x squared plus 5x plus 4. Subtract 8. Distributing. 5 fours are 20 times x squared. 5 times 5 is 25 times x is 25x. 5 times 4 is 20. Subtract 8. 20x squared plus 25x. 20 minus 8 is a positive 12. 20x squared plus 25x plus 12. We're back to letter C again. All right, as I kind of look at these last two domains of composite functions, I'm not going to take the time to test you on this, so I'll go back and I'll change this, that on this practice test you're only doing numbers 1 through 13. Well, you're canceling out numbers 13 and, I'm sorry, 14 and 15. All right, those are domains of composite functions, and I haven't spoken about that. I'm talking about domains of regular functions, but not domains of composite functions. It gets a little tricky, and to be quite honest, I don't think it's worth the time for me to waste a half an hour doing it. Determine whether the graph is symmetric to the x-axis, y-axis, or origin. Well, you see if you fold it along the y-axis here, these points would lie on those, and those would flip over here, so it's y-axis symmetry only. Number 16, that's all you got. Let us see. What else? Let us see. Here, you know, to graph this, I'd have to do something like this. I'd have to solve this for y. Here's what I got. To put this into my calculator, I'd have to do this. I'd have to subtract x to the 4th on both sides. All right. And then take the 4th root of both sides. All right. Now, not only taking the 4th root, but I have to do the plus and the minus. All right. This gets to be, you know, a little too much work. So, here's what he's telling us. If I replace x with negative x and I get back the same function I started with, I've got y-axis symmetry. If I replace y with negative y and I get back the same function I started with, I've got x-axis symmetry. If I do x, negative x in place of x, and y, negative y in place of y, and I get back the same thing, I've got origin symmetry. Well, here's what's happening here. If I replace x with negative x and I raise it to the 4th power, guess what? Negative x raised to the 4th power is just x to the 4th. you know, 4 times. It's an even amount. So it gives me back the same thing I started. If I replace y with next, so I've got, replacing x with negative x gave me back the same thing I started with. So I've got y-axis symmetry. Now, if I put, in place of y, if I put a negative y, and I raise it to the 4th power, ends up happening negative y to the 4th power is just that, y to the 4th. I get back the exact same thing I started with, so I've got x-axis symmetry. Now, it works for both, so it works for minus x and positive x. It works for minus x and minus y. So not only do I have x-axis and y-axis symmetry, I get symmetry to the origin. So x-axis, y-axis. Whenever you have an even power, when you take a negative and you raise it to that even power, it's going to end up being a positive. So I did it here, got back the same thing, put a minus y, did the same thing, and it worked for both of them. So it gave me x-axis, y-axis, and origin. Number 17, letter B. That's the best way of doing that, because to graph this, just enter this into your calculator, and then you have to do the positive and as well as the minus. All right. When you take the square root, or in this case the 4th root, you get a positive and a negative situation. It's like saying this. It's like saying x squared is equal to 16. The square root of x squared is equal to plus or minus the square root of 16, which would be plus or minus 4. All right. Squaring 4 gives me 16, but squaring a negative 4 also gives me. So you have to consider the plus and the minus. But you really don't want to take the time to do all that. It was just as easy to replace x with negative x, y with negative y, and see what was going on. Number 18. Here again, I'm zeroing in on this negative sign, which flips it across the x-axis. So I know it's not B or C, because that says y-axis. And the 7 is going to multiply all the values by 7. Don't forget, the minus and the 7 are 2 different features, right? They're 2 separate things, right? The minus flips it, and the 7 multiplies all your y coordinates by 7. Not by minus 7, by 7. The minus had nothing to do with the 7. The minus told me to flip it across the x-axis. Letter D. 19. Once again, I got this minus sign. All right. And I'm flipping it across the x-axis. I see x-axis here. I see x-axis there. X-axis. This says y-axis. And the 4 is going to... it's going to stretch it by a factor of 4. All right. Stretch it vertically by a factor of 4. So I see it here and I see it there. This says 1/4. All right. So what's the difference between B and D? The positive 6 shifts it up. Positive means up, negative means down. All right, so 19, yeah, 6 units up. What does D say? 6 units horizontally. No, the 6 is not contained under the radical. It's a vertical shift. Positive means up and negative means down. So we got the right one, letter B here. 6 units upward. I don't know what this is. 6 units horizontally. No. 20, I see the minus sign again, and I'm looking for something that's reflected on the x-axis. X-axis, x-axis. This says y, don't want that. And what do we got? Number 20, just looking at these. Stretch it horizontally by a factor of 9. No, the 9 is going to move it vertically. It's not going to stretch anything. And what does this guy say here? Factor of minus. No, the minus and the 6. The minus sign is completely different from the 6. The minus told me to flip it across the x-axis. The 6 is going to stretch it vertically. And it's right here by a factor of 6 across the x-axis and shift it up 9 units. Yeah, the positive 9 brings it up 9. Here again, you could graph that, but it's a process of elimination. I started with the minus sign, and I could have actually gone to the plus and found out which one was shifting it vertically. But there's always going to be, once I get it down to 3, I just nitpicked. I found out why A was wrong and B was, well, B I knew was wrong. Why A and C were both wrong. And it left me with my only choice here, letter D. All right.